Hi everybody, this is Miss Moran and welcome to your first video lesson for our Advanced Algebra 2 class M308. We're going to start here with a little bit of a materials check to make sure that you've got everything you need to take the most successful notes. First of all, are you in a quiet place? You've obviously already got your computer or your iPad or your cell phone ready to go because you're watching me. But are you in a quiet place? Is this the best place for you to be taking notes? And do you have headphones? Because sometimes that'll just drown out a little bit of the extra noise around you. Do you have your notebook and a pen and a pencil? Because you are going to take notes along with this. And are you really ready to watch? Make sure that you've got your mind clear of everything else and that you're ready to take notes on this topic. If that's all set, then let's go. And also, don't forget that you can pause whenever you need to. No need to raise your hand. You can just go to the bathroom if you pause the video. But I'm going to give you a couple places where it's appropriate to pause so that you can catch up with the notes or maybe even try a problem on your own. But you can pause anytime you need to. So at the top of your paper, we're going to write down three things. The first thing is you're going to write down which standard we're covering, and that's always going to be the first thing listed here on my video. So it says function operations. That's the standard that we're looking at. The second thing you're going to write down is video 1.1.1, and that's the reference number. Now those ones have something to tell you. The first thing it is that this is unit 1. The second one represents which standard within that unit we're covering. So this is the first standard. The last one, is which video for that standard are we covering. So 1.1.1 means unit 1, standard 1, video 1. And the last thing you're going to write down at the top of your paper before we get started is what topic is actually being covered in this video. In this video, we're going to be talking about the real number system. So as soon as you're ready, you had all that written down, then we'll go ahead and continue. Pause if you need to. All right, so the real number system. Now you probably know all sorts of things about numbers, but we're going to go ahead and classify those numbers. And the first classification we're going to give are to the first numbers you learned as a child. When you started counting, where did you begin? Well, naturally, you began at 1, and that's what we're going to call these numbers, natural numbers. And your natural numbers are 1, 2, 3, 4, and they go on as far. Another name for those is counting numbers, and that's really what they are. It's what do you use to count. The second classification includes every one of these natural numbers, but it's as a bonus. These numbers are called whole numbers. So whole numbers are all of the natural numbers with the addition of a 0. When I think of whole numbers, I think of, well, how many cans of soup can you possibly have in your cabinet? Well, you could have 0 cans of soup. 1 can of soup, 2 cans of soup, 3 cans of soup. So natural numbers are what you naturally started doing when you started counting. You start at 1. Whole numbers, well, those are numbers that, again, like I say, how many cans of soup are in your cabinet? The next classification are called integers. Now, integers are the most commonly used number or term in algebra. I take that back. It's not the most common, but we do talk about them frequently. Okay, so integers are all of your whole numbers, 0, 1, 2, 3, 4, and their opposites. So that means, and I'm going to use a ... over here, and I'm going to start with -3, -2, -1, 0, 1, 2, 3, and I'm going to put a ... on the other side. So again, this means that, and I'm going to show you here, these ... mean that they go on forever, but because there's a ... or an ellipse on both sides, that means that they go on forever in both directions following this pattern. So they are whole numbers and their opposites. The next classification we have are what's called rational numbers. Whoops, that's a little bit thick. rational numbers. Now, our rational numbers are all sorts of numbers that include fractions, decimals, and whole numbers and integers. So these include all sorts of things, but they must be able to be written as a fraction. So examples of rational numbers are 1/2, 0.3 repeating, and 0.3 repeating can be written as a fraction. It is the fraction 1/3. It could be 5/7, which could be written as a decimal, but it is a decimal that really has no pattern, but it can be written as a fraction. Okay, so we also can have the number, like a number 2.5, that could be written as a fraction. So rational numbers are actually numbers that could be written as two integers. So it is an integer over an integer. And if that's possible, it's considered a rational number. Right. Now we have two more classifications. If numbers can be rational, then there must be numbers that could be considered irrational or not rational. And irrational numbers are numbers that cannot be written as a ratio. Sorry, that is not writing an S. As a ratio of two integers. So these numbers are examples. Pi is an irrational number. We think we can write it as a decimal, but that decimal is an approximation, 3.14. It's not actually the number pi. So irrational numbers are numbers that do not repeat in a decimal form, have no pattern in a decimal form, cannot be written as a ratio, which means a fraction, of integer over integer. These are irrational numbers. Now, so I've mentioned natural numbers, whole numbers, integers, rational numbers, and irrational numbers. What are real numbers? Well, actually, all of these are a real number. So here's a diagram that represents the real number system. And I'm going to give you some symbols that you may see throughout the course that represent the real number system classifications. Our natural number symbol is this double N. I don't care for that. Let's write it again. There we go. It is an N. It's got like a little double. Now, the W is also a double W. An integer, not an I, our integer is a Z with a double Z there. And rational, this one's going to drive you crazy. It's a double Q. The real number system, which includes all of these, irrational doesn't really have one. It does not have a symbol, but we have this double R to represent the real numbers. And you will see us use that real number symbol quite frequently in this class. So let me remind you though, if a number is a natural number, it is also a whole number. If a number is a natural number, it's also an integer. If a number is a natural number, it's also a rational number, and it's also a real number. So let's start somewhere else. Let's say we start right here in the integers. So I have the number -5. That's an integer. Is it a whole number? Maybe, maybe not. Is it a natural number? Maybe, maybe not. So going down doesn't always work. Those are maybes. But going up always works. These are big yeses. So if a number is an integer, it's also a rational number and it's also a real number. Okay, so again, maybe it can go down. It can always go up in this system. Another thing to keep in mind is if it's rational, it cannot be irrational. All right, go back and watch any of these parts of this video that you need to make sure that you've got the best and completed notes, and then go ahead on to Schoology and take a look at the entrance slip and see if you can answer those questions on your own using your notes.